Hello everyone, welcome to I Plus Education. In this video lecture, I am going to discuss one of the questions of beta function. Let us see here. Prove that beta of m comma n is equal to 0 to infinite x power of m minus 1 upon 1 plus x power m plus n dx is equal to 0 to infinite x power of n minus 1 upon 1 plus x power m plus n dx. We know that beta of m comma n is equals to 0 to 1 x power of, here we have m, so write down m minus 1 into 1 minus x whole power of n is there, so write down n minus 1 dx. Now in order to convert this beta m comma n into this function, we have to make certain substitution. Put this value of x as, here we have 1 plus x in denominator. So similar to that pattern, we have to take substitution. Here take 1 plus y. Here we have x power of m minus 1, x power of m minus 1. The coefficient is 1. So take this substitution as x equal to 1 by 1 plus y. Here we have 1 minus x. So calculate 1 minus x. 1 minus x value is 1 divided by 1 plus y. Take LCM. We have 1 plus y. 1 into 1 plus y, we have 1 plus y minus 1. So plus 1 minus 1 get cancelled. We have y divided by 1 plus y. Now here we have dx, that is differentiation. So differentiate x with respect to y. So it will become dx is equals to, treat this as a single term y, then derivative of 1 by y will be minus 1 by y square. We have y as y 1 plus y whole square into dy. Now we have limits for x. 0 to 1 limit is for x. Now we made substitution as x equal to 1 by 1 plus y. So new limits are required for this variable y. New limits for y. Here we have lower limit of x. When x value is 0, substitute x 0 here. Then we have 1 by 1 plus y value is 0. Since x value is 0 here. Now from this cross multiply this. Now we will have 1 by 0, 1 plus 5 value is 1 by 0. 1 by 0 value is infinite. So 1 plus y is infinite, means y value is infinite. Now when upper limit x is equals to 1, substitute here x value 1 here, then we have 1 by 1 plus y value is 1. Now cross multiply, we have 1 plus y value as 1, then we have y value as 0. This beta m comma n will become integration 0 to 1 for x. Now for y we have lower limit is infinite, y equal to infinite to 0, x power of m minus 1. So x value is 1 by 1 plus y whole power of m minus 1 into 1 minus x. 1 minus x value we have y by 1 plus y. Y by 1 plus y whole power of n minus 1. Here we have dx. Dx value is minus 1 by 1 plus y square dy. Now take this minus outside. Here we have infinite to 0. 1 power of m minus 1 is 1 only, divided by 1 plus y power of m minus 1, distributing this power to numerator as well as denominator, into we have pi power of n minus 1 divided by 1 plus y power of n minus 1 into we have 1 divided by 1 plus y square dy. We know that minus integration a to b f of x dx can be written as integration b to a f of x dx. That is, this negative sign will interchange these limits. A to b will become b to a. So applying that concept here, this negative will make this as 0 and this 0 as infinite. So we have 0 to infinite y power of n minus 1 divided by, here bases are same, then power should be added. So write down 1 plus y power of m minus 1 plus n minus 1 plus 2 dy. Now this beta m comma n is equals to integration 0 to infinite y power of n minus 1 divided by 1 plus y whole power of m plus n minus 1 we have minus 2 plus 2 will get cancelled. We have dy. Here this integral is in terms of y. This integral can also be expressed in terms of x. So replace y by x. Then we have beta of m comma n as integral 0 to infinite. Everywhere replace y by x. So it will become x power of n minus 1 divided by 1 plus x whole power of m plus n dx. Beta m comma n equal to 0 to infinite x power of n minus 1 1 plus x whole power of m plus n dx. We got this. Now we want this x power of m minus 1 by 1 plus x whole power of m plus n. By the property of beta function, that is beta, we have this property beta m comma n can also be written as beta of n comma m. It means that we can interchange the values of m n. So here it will become beta of m comma n is equals to integration 0 to infinite. In place of n we can write down m. So x power of m minus 1 divided by 1 plus x whole power of n plus m dx. So n plus m is also m plus n. So we got this relation also. Now let us solve this question. Prove that beta of m comma n is equals to 0 to 1 x power of m minus 1 plus x power of n minus 1 upon 1 plus x whole power of m plus n dx. We know that beta of m comma n can also be written as 0 to infinite x divided by 1 plus x whole power dx. Here this power of 1 plus x will be the sum of these two values m plus n, and here I can take m minus 1 or n minus 1. Just now we have proved this relation of beta m comma n. Now using this relation we can prove this. Here we have 0 to 1 as the limit of this integration. Here we have 0 to infinite. So this 0 to infinite limit can be splitted up into two limits, that is 0 to 1 and 1 to infinite. So splitting the limits of 0 to infinite as 0 to 1 and 1 to infinite. So this beta of m comma n is equals to this integration 0 to infinite will become 0 to 1, this function x power of m minus 1 divided by 1 plus x whole power of m plus n dx plus 1 to infinite x power of m minus 1 by 1 plus x m plus n dx. What we did, we splitted this limit 0 to infinite as 0 to 1, next 1 to infinite. Now consider this as equation 1. Let us solve this part first. Let this integral be I. Let I is equals to integration 1 to infinite x power of m minus 1 divided by 1 plus x whole power of m plus n dx. Now by proper substitution this integral can be solved. Put x as 1 by y. Let us make a substitution x as 1 by y. Now differentiate this. Differentiate x with respect to y. Then we have dx is equals to minus 1 by y square. Derivative of 1 by y will be minus 1 by y square dy. Now here we have limits from 1 to infinite for variable x. Now we want limits for y. So new limits are required. New limits. Lower limit of x we have 1. 1x is 1. Substitute this x 1 here, then we will get y. Y is also 1. Next, substitute upper limit when x equal to we have infinite. Substitute infinite in place of x, that is 1 by y value as infinite. That implies y is 0. If you substitute y 0 here, 1 by 0 will make this infinity. So definitely y should be 0. Now this integral I is equals to integral 1 to infinite for x, 1 to 0 for y. So we have 1 to 0 x power of m minus 1. X value is 1 by y. So 1 by y power of m minus 1 divided by 1 plus x. 1 plus 1 by y m plus n into dx. Here we have dx. So value of dx is minus 1 by y square dy. Now this minus sign will interchange this limits. It will become 0 to 1. 1 power m minus 1 is 1 only. So write down 1 divided by y power of m minus 1 divided by, take LCM here, y ones are y. So we have 1 plus y power m plus n divided by y power of m plus n into 1 by y square dy. Now this term will come to the numerator and this term will come here. So this I will become integration 0 to 1 into y power of m plus n. So it will become y power of m plus n divided by y power of m minus 1 into 1 plus y, 1 plus y power of m plus n into we have 1 by y square dy. Integration 0 to 1. Here we have y, y, y. Take this y, m plus n. This power minus m, this m minus 1 will become minus m plus 1 to the numerator, and this plus 2 will become minus 2 in numerator. So we have, now we are left with 1 plus y whole power of m plus n dy. We have selected y terms, y, y, y. Now 0 to 1, we have this 2 will get cancelled, we have n. 1 minus 2 we have minus 1 divided by 1 plus y whole power of m plus n dy. This is the value of integration I. Now this integral is in terms of y, so this complete integral can be expressed in terms of x also. So replace y by x, replace y by x. It will become integration 0 to 1 x, y will become x power of n minus 1 divided by 1 plus x whole power of m plus n dx. Now here we have beta m comma n is equals to integration 0 to 1 x power of m minus 1 divided by 1 plus x power of m plus n dx plus this integral. The value of this integral we have 0 to 1. So let me write down here 0 to 1. We have x power of n minus 1 divided by 1 plus x whole power of m plus n dx. Now we have common integral here 0 to 1, 0 to 1 dx, dx. Take integral common. We have integration 0 to 1 dx. Now we are left with these two functions. Numerator is different, denominator is same. So taking LCM we have 1 plus x whole power of m plus n. Now add the numerator. We have x power of m minus 1 plus x power of n minus 1. Now we got this result 0 to 1 x power of m minus 1 plus x power of n minus 1 upon 1 plus x whole power of m plus n dx. Now this is the solution.